We're looking at r/askmath today. I saw a question that I thought was actually kind of cute, and this is just a straight up math question, so I'm running a very low risk of misunderstanding this one. Someone was looking at a math book on Amazon. It's like a collection of, problems, puzzles, brain teasers, and the book, you can see the listing here, it looks it doesn't look great, but it has a little sampler of problems on the front, and even though the front, to me, aesthetically looks kind of jumbled and not super appealing, some of the problems are a little neat. There's one in particular, just for fun, we'll solve all of them while we're here today. But the first one, question 65, is what the OP is asking about here. Find the perimeter of the given figure. OP says he found the book on Amazon. Question on the cover looks interesting, but seems it's incorrect, and that it's not possible to find the perimeter of the figure. So this is actually just a neat little, find the perimeter of the given figure type problem. You've probably seen problems like this. You've got a slightly strange rectangular type of figure. Some of the measurements are labeled, a few are not. You got to try to piece everything together to find the total distance around the shape. So here's that perimeter problem that OP was asking about. We've got 3 of the pieces labeled. 14 on the right, that's not causing us any problems because we can see this, and this are going to add up to equal that 14. So in total, that's 28 units contributed to the perimeter. Where things get a little puzzly is with the other direction, looking at all of these horizontal segments. How do we add up their lengths? We know we've got the 11 and the 8, but it seems like we either need to figure out the length of this slice here so that we can add it to 8 to figure out what this is, or we need to figure out what the length is of this slice here so we can add 8 and 11 and then get rid of that part so that we've accurately counted that segment. And unfortunately, there's no way to figure out the length of this little segment. Thinking that you need to is one of those classic mistakes with math problems. There are many types of problems where you're trying to figure out some sort of whole. Often it might be something like x plus y. And you feel really tempted to solve for x and y individually. But for one, it's not necessary for the problem, and sometimes it might not even be possible, which is what we see in this case here. You have to just push forward with the information you've got and realize that it actually works out perfectly. So if we can't find the length of this shorter segment, then how do we use this information to figure out the length of this longer segment? Well, what actually happens if we add 8 and 11 in order to, say, calculate the length of this segment? Of course, that's not accurate, but what happens? What's the error? Well, if we add 8 and 11, we are going to get the length of this segment, and we're going to get a little bit extra. That extra, of course, is this length here, because that's part of the 11, and that length is also part of the 8, so we get an extra one of those. But that's actually perfect, right? Because we need an extra one of those in order to count this here. So by adding the 8 and the 11, you get this with a little bit extra. And what's the extra? It's that other unknown piece. So adding 8 and 11 gives us exactly what we need. It's these 2 unknown pieces. So in total, we've got the 14 going that way. We've got the 14 going this way, so that gives us 28. And then we've got 11 and 8, and 11 and 8. So 19 times 2, so 38. So final answer then is 66 units is the perimeter of the figure. Pretty cute little problem. All right, you can see though that on the front of the book cover, just available as a sort of sampler, we've got 3 other problems. So, hey, why don't we go ahead while we're here and solve those problems too? I've blown them up in all their blurry glory. You can see what this one is, question 66. We're trying to solve this product, evaluate the product. 1 minus a half, 1 minus a third, minus a fourth, minus a fifth, and so on. So how do you do this? We've got 100 factors. That seems like a lot of work. Well, just start in the parentheses. If you evaluate what's inside all of the parentheses, this turns out to be a very easy calculation. 1 minus a half, what's that? That's just a half. 1 minus a third, what's that? That's 2/3. And this pattern's going to continue. 1 minus a fourth over here, that's 3/4. And so on. So what you're going to have for each factor here is a numerator, which is counting up the natural numbers, and a denominator, which is 1 greater than the numerator. This is going to continue all the way up to that last factor, which we see over here, 1 minus 1 over 100, is going to be 99 over 100. And then it's really easy and snappy to rewrite this as a quotient of factorials. In the numerator, 99 times 98 times 97 all the way down to 1, that's 99 factorial. And in the denominator is 100 times all those positive integers less than it down to 2. That's 100 factorial. Of course, the multiplication by 1, we don't see it there, but it doesn't matter. 99 factorial over 100 factorial, everything cancels out except that final factor of 100 in the denominator. So final answer is 1/100th, or 0.01. Nice little problem. All right, here's the third one with light bulbs. This one is the hardest. We're shown a sequence here of light bulbs, and we're asked if the 97th bulb is illuminated or not. So I'm assuming these ones with the sort of shining the minus signs around them, those are the light bulbs that are illuminated. And it follows a simple pattern that you can probably see here. It's a light bulb that's not illuminated, and then one that is, and then one that's not, and then 2 that are, and then 1 that's not, and then 3 that are, and then 1 that's not, and then 4 that are. So the illuminated bulbs are appearing in groups that are going up by 1 each time, and these groups are separated by dim bulbs. And of course, it starts with a dim bulb here. Several ways you could go about this. I mean, this is really just a sort of basic counting problem. Find some way to systematically count up the bulbs while keeping track of which ones are lit and which are not, and then see where the 97th bulb falls. Is it glowing or is it not glowing? I think a snappy way we can solve this is to look at the groups of the lit and non-lit bulbs as a whole. And if you do that, the number of bulbs works out to be something you're very familiar with. So if we start by just looking at, here's one bulb, it's the dim one. Okay, now from now on, each group we're going to focus on is a set of lit and unlit bulbs. So then we've got 2 bulbs here. It's the 1 lit and the 1 unlit. Then we've got 3 bulbs. It's the 2 lit and the 1 unlit. And then we've got 4. And then we'd have 5 and so on. In each case, the groups are going up by 1. 1, 2, 3, 4, 5 bulbs and so on. And each group is ending with an unlit bulb. So this gives us an easy way to add them up, and in groups where we know the last member of each group is an unlit bulb. So if we're adding up these counts of bulbs, it's 1 plus 2 plus 3 plus 4 plus 5 and so on. If you look at these partial sums, it's triangular numbers, and you're perhaps familiar with the formula for those. If you want the nth triangular number, the way to calculate it is n times n plus 1 all over 2. So the question is, where does the 97th bulb fall, in this line of light bulbs? To find that out, you'll want to plug an n in here that's going to get us near 97. So let's say we try n equals 13. Then we're going to have 13 times 13 plus 1, so 14 all over 2. 14 over 2 is 7. So this is just 13 times 7, which is 91. So that means 91 bulbs in, we are at the 13th group of bulbs. And the 91st bulb, the very last member of that group, is going to be one of those dim bulbs that are closing off each group. And because this is the 13th triangular number, that final group in the count has 13 bulbs, which means the next group has 14 bulbs, the first 13 of which are going to be illuminated. That, of course, is going to get us through to the 97th bulb. So I'm saying from the 91st bulb, the next 13 are going to be illuminated. That would take us to the 104th bulb, which of course means that the 97th bulb, yes, absolutely is illuminated. So you can do all the math you need to do here pretty slick and quickly, just with triangular numbers. Pretty neat. Well, let me know if you have a different strategy for this one in the comments, or any of the problems. But this one's pretty easy. It's just a matter of how you count it. So kind of neat. And then the last problem here, this one's really trivial. All the others were like really nice levels of difficulty for someone, especially who's trying to like get back into the practice of math. Like they've always been kind of good at math, but maybe haven't done it since high school, and they want to try testing their mettle again. But this one's just totally trivial. Let's see. There you go. Problem solved. The weight the weight is balanced, the scale is balanced. It's 250 weight units on each side of the scale. So if you found some other way to add these weights together to get 250, you could do that too, but that's it. And yeah, I don't think there's any other way you're going to get 250 out of these weights. So there's your solution for question 33. So interesting. I wonder what the rest of the puzzles in that book are like. I could make it a tax write-off, but I'm not gonna. I just spent a bunch of money on a math book, which I am looking forward to telling you guys about, hopefully in the next week or two. But for this one, impressive, nice little sampler of problems there. Maybe it highlighted the best ones, but those first three are pretty nice little problems.